This is the weekly update for Mr. Fix's class for the week of August 22nd. Homeschool Connection, let's take a look at that. Homeschool Connection was assigned on Monday this week and was collected on Thursday. So students had to read about this imagined situation. They then had to choose which thinking they agreed with, A, B, or C. They then had to describe their thinking and explain why they chose the answer they did with 2 sentences minimum to get full credit. Then they had to work with somebody at home, write down their name, what they chose or what they thought, A, B, or C. Then they had to explain why they chose what they did. They had to record their explanations below, again, 2 cents minimum. And then we had a challenge that was required. They had to pick 2 items from the same place that felt different temperature. They had to name the 2 items and describe how they feel, which one felt warmer than the other. So we did that, and in class on Friday, I passed them back and went over it. And basically, most students chose B. The thermometer stays the same temperature. Sorry, the thermometer inside the mitten will have a higher temperature reading than the thermometer on the table by itself. Most people chose B, but the correct answer was actually C. They didn't get penalized for choosing B. What we want to do is bring to the surface their misconceptions about the idea. Most people chose B because they thought, like human beings, which if they put on a mitten, their hands will feel warmer. Thermometers aren't like living things. You think of like a dead person versus a live person. A live person has a 98.6-degree temperature internal, where a dead person would have whatever temperature there would be around them. So it shows that things that generate their own heat, like human beings, act differently than things that do not, like thermometers. So it's to surface their misconceptions and confront their misconceptions with the reality of the science behind it. Students did the beginning of the year questionnaire as well on Monday. Students went over and glued in page 2 and 3 in the Science Safety Notebook. Page 2 is Science Safety Agreement, and also page 3. So we went over all the rules on the Science Safety Agreement, explaining that these rules are there so that we reduce the likelihood of accidents in the classroom. Accidents can lead to breakage and injury, so we're trying to reduce that with how we act in the classroom. So we went over them, and they signed their names at the bottom of the paper acknowledging that they did that. We then did an activity called plane crash, where it was a scenario in which a plane of passengers crashed into the snowy wilderness of northern Canada. They had these 12 items, and they had to rank the items in terms of their importance, their survival. They did individual rankings by themselves. They then got into teams and did team rankings, and then we wrote down the experts' rankings. And then we calculated how far away the individual was to the expert, and then calculated how far the team was from the expert. And we compare the total individual score to the team. So sometimes teams scored better than individuals, sometimes individuals did better than teams. So that is to think about collaboration. What is collaboration? How does it work? So basically, a team can do better than an individual because they bring different knowledge bases and skill sets to the group, whereas a person by themselves, good chance they don't have that type of knowledge base and skill set. Then on page 4 and 5 of the science notebook, we glued in the norms of collaboration. These are 6 norms that students will work on to improve throughout the year so that they have a greater chance of their team achieving their goals. So that was on page 4. And page 5, they rank themselves at this moment in time on each of those norms. And then on page 6 and 7, we glued in the science, writing, and talking sentence starters. So when they communicate with each other on science activities, they know how to speak when they're working with ideas, wondering and generating questions, and noticing and observing. So we did that as well. We started the observator activity, and so students were given an observator, and they had to record their observations about that observator. Basically, what did they notice about the object? They used their science sentence starters in their notebook to help them along with this. So they use their sentence starters to help them talk with each other on what they noticed about the observator, about that disk. and they recorded information such as flat shape, circle shape, smooth on one side has raised grid pattern, 6 pieces of tape, on the edges printed letter. And then from their observations, they derived a question: what does it look like inside? And then they made two hypotheses, and then they were able to look at the results and see if they matched the results. Now, it doesn't matter if they match the results or not. What matters is if they got results that are conclusive. Thing you can actually make sense of the results, and that's how science works. If we don't have results that make sense, then science just has to go back to the drawing board and try to figure things out, come from a new approach on things. Then we did Save the Penguins, an introduction to it. So basically, the Save the Penguins project is where students become engineers that have to solve a problem by building something. So the problem is basically the penguins, and we go through what's going on, where they live, what kind of things they face, how does thermal energy affect them, and what we can do to help save the penguins. Basically, they're going to build a shelter that tries to minimize the amount of thermal energy that gets to the penguins. So that's what we did this week. Hope you have a good weekend. Bye bye.